So our second day today, we're going to take a look at what is a geometric sequence. So let's take a look at this warm-up, and I want you to jot down all the things you notice and wonder about this. So I take a look at this one, and I notice that 2 are getting bigger, and some are getting smaller. I notice that this one, like it's getting smaller by half, where this one is getting bigger times 4. So all sorts of different things you could notice in there. And I wonder like how you would predict the 100th term. So what we're going to do today is we're going to take a look at a task of paper folding. So our task for today, why is this not going up? There we go. Vasa takes a piece of paper, cuts it in half, then stacks the pieces. She takes the stack of 2 pieces, then cuts it in half. She keeps repeating the process. So here's our 8 by 10 sheet of paper. So 0, how many pieces are there? There's 1. And it's 80 square inches. So if she cuts it in half, then we have 2 pieces, and the area would be 4. If she cuts it in half again, 4 pieces, and the area would be 20. And then cuts those all in half, so there would be 8. It would be 10. Cut those all in half again. It has 16, and that would be 5. And 32, and then each would be 2.5 in area. So describe in words how you can use the results of 5 to find the results of 6. Well, the pieces, it's times 2. But the area is cut in half. On the axis, sketch the number of cuts for pieces. So at 0, we had 1 piece. At 1 cut, there was 2. Then it went to 4, 8, 16. I don't know why this is not working here. There we go. 16, 32, and then it would go up to 64. This is reminding me of last chapter a little bit, an exponential. Sketch the area. So 1 piece started at 40, 80, then it dropped down to 40, 20, 10, 5, 2.5, and it keep getting smaller. So if you remember, these are those exponential equations there. So if Faisa has a piece of paper that is 8 by 10, how many cuts will she have after n times? So if you guys remember, this one starts with it starts with 1, and our growth rate is 2. So 1 times 2 to the n. And what is the area? Well, our area, it starts at 80, and then to the n. And then think about this one. Why is the product of the number of pieces in the area 4 the same? And how do you know that? Well, our total area is always 80. So the pieces times our area has to equal 80. So what we did today is we found a geometric sequence. And a geometric sequence has a common ratio. So it's when you're multiplying to get the next term. The common growth ratio, or the growth factor, is R, and it's what you multiply by. So when we're taking a look at this, let's see, how do we get from here to here and here to here? Well, I noticed that we're multiplying by 2, so this one would be 12, and this one would be 48. And if I was ever unsure, how would you figure it out without? Well, 6 divided by 3 is 2. 3 divided by 1.5 is 2. So we could always take a term and multiply by the term before. So for example, this one, how do we get it? Well, if I'm not sure, what's 120 divided by 40? That should be the same as 360 divided by 120, which I know is 3. So times 3. So 360 times 3, 1080 times 3, 3,240. So how do we get from here to here? And I think, sorry guys, that's supposed to be 200. Well, what's 200 divided by 20? And is that the same as, excuse me, I did that the wrong way. 20 divided by 200. And what's 2 divided by 20? Well, that's 1/10, so divide by 2 is 1. Excuse me, divide by 10. So that's, I can't talk right now, I'm sorry guys. So that's 1/10. So times 1/10 would be 1/5. Times 1/10 is 1/50th. So what about this next one? 1/7, 9/7, 27th. Well, I noticed the denominator is the same. So what's happening at the top? Well, that's times 3. So times 3 is 3. Times 3, 27 times 3, 21, carry the 2, 6 is 81. So what is this? So we're multiplying it by 3. And how about the last one? Well, we could say divide by 2, but we always say what we're multiplying to. So divide by 2 is the same as times 1/2. So our ratio is 1/2. So we have 3 and 1.5. So with your group, I want you to see if you can come up with your own geometric sequence and why it's geometric. And let's see, is 2, 2, 2 a geometric sequence? Why or why not? Well, if we say, well, we take a term and divide it by the term before, our ratio is 1. So yeah, because we're multiplying by 1 each time. So our ratio, common growth factor, is 1. And then the last one, if you had a sequence 1, -1, what could be the next 3 terms? Well, I could say I'm multiplying by -1, so it could be 1, -1, 1, -1, and that's with a growth factor of -1. But I also might say I'm subtracting 2. So it could be -3, -5, -7, which is not geometric.